Oh, let's see. It looks like it's working. It looks like it's working. We like working stuff. All right. Let's see. So, what can I do while we play around with this stream and make sure that people see it, and then tell me if this is working okay. So, let's see here. Yep, it's green. We like green stuff. All right. Okay, how long has this thing been running? Where do I find that? A minute. A whole minute. Oh, Sunday night. Anyway. Oh, maybe I'll play with this instead of this. Well, that works. I need a power cord. Okay, power cord. Actually, I'm testing this new bench. I've just got everything set up on here, and so I figured that I would test this. Looks like that was part of the serial number label that just, well, bye-bye. I don't know. I was looking for something to tinker with. So, you know, just to make sure that this is, you know, doing the business. So, this is a Robin SB510D, and if I remember correctly, this is non-functional. So I don't know. I guess I would give this thing a tinker and see if it can be revived. So, you know, it's late on a Sunday night. I really wanted to more or less test the camera to make sure that you know, everything was working. So, yeah. It says there's 7 people now, but nobody's really saying anything. So, emails, yeah. So, I guess I need to figure out. Oh, that's not going to work. Oh my. Yeah, so I got to find my stuff because everything in here is still sort of, you know, ajar, if you will. So now I got to find out where my clip leads are, so that I can hook that up. Here's a in the wire pile, because yeah, everything got dumped in a pile. So here's some in a wire pile. These are not the ones I want, but they'll work in a pinch. Yeah, these are the ones I want right here. These ones. Is it really? And the funny thing about that is that this blue, this is a new mat, because this is a whole new bench. This is actually a new mat. And I think the other one looks darker, actually. I wonder what it could be. It looks actually okay on the preview. Like that's a greenish color. The wires are red and black. The light may not be as good because I've sort of tweaked the lights to try to not be so bright, because I think the lights, the way I had them before, would trigger the camera to do the focus, you know, search. So if I turn on a bright light, you know, yeah, that spotlight, I mean, yes, it is actually LED lights. None of these bulbs in here are incandescent. So this is a spotlight. And, you know, so I can sort of wiggle it around. But it is also an LED. And I thought it was just too bright. So I just left it off. You know, so that's funny because the preview actually looks okay. It could be. And maybe I need to think about the, you know, doing something a little differently. The only problem is that to me this is dim, but on the screen it looks okay. I do look pale in the preview, you're right, and I'm not that, trust me, I'm not albino. In fact, I am pretty light. Don't get me wrong, I'm actually coming off of a sunburn. So I'm actually a little darker than usual because of that. But yeah, I'm not really too sure. I'm probably going to have to tinker around with the lighting. I'm not a you know, video expert kind of a person. So fortunately, I have people I can call and say, hey, look at this video and tell me what the hell I'm doing wrong, and help me get it sorted. So yeah, now what do I do with this? Because this is in the way. So, does it? I mean, my hands do look pale. He's right about that. Like, I'm looking at the preview, and I'm looking at my hand. I mean, just look at the screen, look at my hand. I mean, my hand looks pale. That's, yeah, there's definitely something to that. I mean, it looks funny. So, anyways, I figure out what's wrong with this thingamabob here, this robin. I think it was not dead, but close to it. Yeah, this is much. I don't have a power cord for these. I probably should get one. Yeah. White balance. Well, you know what? I can probably tinker with some of this. I wonder if I can configure video. Contrast, brightness, white balance is set to auto. Let me see what the camera's settings are here. Brightness and white balance is set to auto. What happens if I take it off of auto and let me make it drastic? Woo! Yeah, I can see the difference. Yeah, it almost made things look somewhat purple. All right, so right there is one extreme. Like, the white balance goes to from left to right, and I have no idea what it does. That's all the way to the right. Right there. So, yeah, all the way to the right, all the way to the left, which makes things look purple as all get out. And that's auto right there. Which, oh, yeah. Actually, that looks a lot better. That actually looks more normal, come to think of it, right there. That looks more normal. I don't know about you guys, but that actually looks more normal. So maybe that right there is what we want, because it does look better on the preview. So, why don't we just save that and let that ride and see what that does for a while. So if I remember correctly about this thing, it didn't receive, it didn't transmit. I happen to have a coffin microphone here that says Cherokee on it. Well, help to plug it in the right direction. It does not transmit, although it's a relay controlled radio, it should. So, I wonder. So is the video stuck now? The video looks like it got stuck. So what did I do wrong here? Let me... what did I do? Yeah, the video got stuck. When I played around with the camera settings, oh, there we go. Okay. Yeah, the video got stuck. Actually, what's funny is you can see the fan on the ceiling reflection in the radio. You can see the fan on the ceiling. Yes, the fan is on. As you can see, it's spinning. That's pretty cool. Camera, I mean, that's pretty good. It looks good. But, you know, it's a good camera. So, now what's up with this radio that PACB? No, that's definitely squelch pull dim. That dims it. That does not cause the thing. When I tried to put it in the wrong way, it seemed like it wanted to transmit though. Yeah, see? The microphone wiring on this must be different than 4-pin Cobra wiring, which maybe that was my problem the last time, is I didn't work and I didn't think it worked, and it actually does. But I've just realized when I'm sitting here tinkering with this, I don't have a dummy load on this bench yet. I have not put my dummy load in. So it's sort of moot because there's no dummy load. So yeah, transmitting is not going to happen. So yeah, but I'm starting to think that, because I put that in wrong, and yeah, it's going into transmit. It's just wiring, and that's for the Robin, incidentally. This is, I know, regular Cobra, which was, man, I don't even remember anymore. I bet you they're flipped around or something. I bet you that they're flipped around. Let's see, this is 1 and 2. And that's 3 and 4. So that's receive. Yeah. Oh, that's, yeah, that's got to be the receive. A Ferris. What, this radio? It's a Robin SB510 Delta. I think you can see that. It's a fairly common 858 radio. At least it's like the Washingtons, and several radios had this board in it. You know, has your good old crystal filter. Yeah, it has a pole switch on the squelch, which is a bright dim control. Come on. Yeah, the pole control and the squelch dims the display. Did they? I'm guessing that yes, because it's an 858. It's basically the same board as like a Washington. I think some Madisons had this board in it. before, because there were some radios that were sort of hybrids. They had a board like this in them, and case in point, what happens to be sitting right here is a Washington, and there's your Washington, and you can see the boards are virtually identical. Virtually identical. So, yeah, that's the Washington. This is a Washington, and this is the mobile variant, even down to this little board that they got in here. This transformer is not present in this because this is just, it looks like it's coming in from a, yeah, it is just coming in from the power connector into this. This is just a common mode filter. So this wouldn't have it. But yeah, basically the same radio. You know, notorious for having these channel selector ribbons be a problem because it's just a piece of flat flex. And this up here, as you can see, this one has had these wires on it and this glue because this one had been repaired. And that's the same thing as right here. These things, if you work on them and you bend this right here, you'll break this little flat flex, and that's it. She's done. So this one is intact. This one hasn't been broken. So, which is actually uncommon to see, because usually at some point somebody's been in these radios and they've bumped this around and they've broken the flat flex. So, which is what happened on this Washington. But yeah, so you know, this is obviously no face. It's a parse radio. So, but it is I believe it's the same board. The board number on this one is, let's see if I can find it here somewhere around. Board number, where are you? Maybe on the bottom. We got Uniden there. We got nowhere that I see the number on the board, but this one's more. There it is, over here. Okay, PC196 Alpha Edward on the Washington. This one is PC353 Baker. Interesting. They're not even close, the numbers. That's, yeah, that's, no, I can see differences, actually. I can see differences. For example, underneath this harness, you got this harness here, you see this crystal filter and this inductor or transformer, variable inductor or transformer right here, and then this heavy ceramic resistor or cement resistor here. On this radio, there isn't a cement resistor; it's a wire wound, you know, a you know, more modern-ish, just wire wound resistor, and you can see underneath the harness maybe that the filter is not present right there, and there's a spot for the transformer that just has a jumper link going from one of the positions of the transformer to the other side of where that filter was. So this radio doesn't have this these two components. So, you know, that's interesting. This capacitor position here is also empty on this one, but this one has a capacitor. It also has a resistor silk screen in there that's not present as well. So yeah, there's some subtle differences on these boards. So, but yeah, since I don't have a dummy load and I don't have a microphone, I got to figure out what the Robin microphone wiring is, and this was really just meant to be a test. So, by all means, guys, what do you think? Other than tweaking the lights and the camera and all that, you know, doable, or do I need to go and go back to the drawing board on this? you know, I'm hoping that that this is going to be fine. There's a lot more space here. I mean, there's get a tape here. This is the edge. Actually, it's the same camera. It's just just better, I think, positioning really. So this is a tape, and so as you can see, it's just hooked onto the edge of the table. So this is about where I see my fingers, and yeah, I'm gonna have to tweak things for sure on that. And this is 6 inches or 15, 16 centimeters right here. And the edge of it over here is 97, 98 centimeters or about 39 inches. So, you know, more room than I had on the other table. Not quite as deep, I don't think. But, you know, I don't need a whole lot of space. So, you know, I think this will do me just fine. I needed space for gear more than I needed space to work. Because, I mean, I work on small stuff. So, you probably did. I believe you did. And the box of microphones is actually behind me. So I should have a look in there. Superstar, that definitely wouldn't be it. Uniden, no. Uniden, no. Uniden, no. Cobra, no. Another Cobra, no. It's probably here. Uniden, definitely not. I don't know. It's around somewhere. President, same difference. Or I tell you who has it. My little guy might have it. He comes in, not so much anymore. He used to raid the microphone box all the time. But no, it's not in this one either. Well, I have a Robin microphone, but it's not for that one. It's for that other one with their Kerklunker relay driven thing, that ancient beast. It's around somewhere. I got a lot more to do in here, so if not, I'll just make one. I mean, no big deal. That's what I mean. He's probably got the thing somewhere. Let's see. For those of you who ask about boards, yeah, I've built more. I built more earlier. I gotta flash them. So, for those who are waiting for these, I just built these today. Coming soon. I think those 4, in fact, are already spoken for. So, in other news, while I'm at it, encoders. I'm trying different encoders. This is a fairly expensive encoder. These are about $15 US. But, you know, and if you take a listen, you know, it's like a channel selector. It's very, very, very solid. Very, you know. So the only problem with these things are they're 15 blasted dollars. You know, so they're expensive. So, well, I only got 2 of them, and I have to adapt the board because these are not a standard footprint, PEC type footprint, at least not 11 or 12. These are the PC20 footprint. So, you know, expensive encoders aside, because they are, but they're, you know, very, you know, clunky. You know, you put a knob on them and it's going to be, you know, clunk, clunk. You You know, they're not really. You can turn them, obviously. I could, you know, I've turned them, but it's not like, it's not quite like a channel selector like this. You know, like you can hear that. Well, if you're interested in these are expensive. The detents on these are about the sharpest that I've seen on an encoder. I mean, I'm sitting here in front of the blasted computer, unlike before. Now I actually have my regular computer at my disposal. So I'll tell you where I got these. I got them cheaper from a Chinese seller on eBay than you could get them from DigiKey, because the DigiKey, I mean, they're $15 a DigiKey. I mean, you know, these are the real deal. I mean, these are not knockoffs. I mean, they're the real deal. But I was able to save $5 US getting them from, you know, China. I'll put a link here in the chat, and there it is. So that is what these are, and you can get the data sheet. I think the listing has the data sheet. It has the model number. You know, they're 18 pulses, but they have the specifications on it. You know, I mean, it is a real, you know, the real thing. You know, I am looking, you know, right at it. I mean, these are the real deal. They're harder than a channel selector. So I think people will probably be happier with these. But the problem is they're bloody expensive. You know, $15 a DigiKey for it, you know, but it's, you know, you can hear it. You know, it's not wimpy like, you know, one of these. I mean, you can hear it, but I can just sit there and spin this without any, you know, real force. But this one, I can't just spin it like that. You see, I can't do that. I gotta I gotta put my finger on the D, and I gotta really grip it, you know, to turn it. I can't just flick it, you know. So, you know, it's like these. I can't just flick this either. You know, and this, of course, you know, easy. So, you know, detents definitely better on these encoders. You know, but the thing is, I mean, this compared to a PC11 type encoder, you know, like this, I mean, you can see the size difference there. You know, I mean, this is, you know, it's probably not going to fit very well in a mobile radio. That's kind of the problem. I will have to make new boards because these use a different pin configuration. They have 5 pins, but I don't know if you can really see the pins on this. You see how the pins are? So you got the 3 in the front, and then the 3 unused next to it, and then the ones that are behind it, the 2 that are behind it back here that may not be very visible. Shouldn't really take any, I don't think, software changes for these to work, because I use QDEC on XMegas, which it's a piece of piss to use, you know, QDEC. For those who don't know what QDEC is, it's a quadrature built-in. Some Atmel AVRs have built-in quadrature decoding, so you know, 3 lines of code to use an encoder in it, kind of thing. So the issue is with these is the space, the size. You know, they're really. Yeah, I'm gonna have to go to AliExpress and get 2 for $15 then, and just get more of them, because I quite like these. The only problem is the shaft lengths are longer. Like this is the right shaft length for a mobile radio, and as you can see, you know, we're talking seriously longer. Now this is probably maybe the fifth or the sixth time I've actually tried getting various encoders, because I've gone to some of these companies and inquired about, you know, getting encoders, and the problem with them is they want to sell you a lot, like 1,000, and it's like, that brings me to the next question about these things, because people ask me this question all the time, these boards. How many of these boards have gone out the door? Well, I'm actually coming up on 100 pretty quick, believe it or not. Almost 100 of these things floating around out there now. I think these 4 make 92, 93, 94, and 95. Yeah. So yeah, I'm coming up on 100, which is a shit pile. That's a shit pile of boards to build. And I've only had 2 duds. So, in fact, is it this one? This one's a dud. It's the second dud. The first dud had a bad track somewhere in there, and it had a bodge wire. In fact, I still have it around because it's just a matter of fixing it with a bodge wire, but I'm not going to obviously sell it to one of you with a bodge wire on it. So it works. It's around here for a test board. So yeah, no bodge wires go out, because it just had the trace over etched or something like that, and it just didn't get caught in electrical testing. So I assembled it, and yeah, it didn't work. So yeah, I just have to make a board for these, but I don't know. These are going to be, I'd like for them to be mobile, but I got to find one with shorter shaft length, because this is, I mean, the problem with it is the body on them is fairly deep. I mean, you guys could look at the data sheet and see what I mean about the draw. Look at the mechanical drawing of it. These are actually pretty big physically. So, but that's the problem with physically big. You get that nice, snap to them, but that comes at a cost of obviously the size. So, anyways, I'm glad that this camera situation worked out. I need to fix probably the lighting. Yeah. So anyways, in other news, I mentioned these things that I got to muck around with PLLs. I'm just gonna look over across the bench here. The 4352 and the E4406. To muck around with PLLs, and mucking around with PLLs, I've come up with this beautiful PLL design here on a breadboard, which, well, yeah, it's on a bloody breadboard, and this is a PLL active loop filter and all that other wonderful stuff. Comes out to fairly good on phase noise. Hopefully I can get the software going for the 4352 that I can show it, with the computer, because I can capture the window on the computer and show it, so that I can talk about phase noise, since I have one of those wonderful instruments that measures it. Phase noise. I mean, it's a PLL VCO analyzer. So, incidentally, I hooked up a Cobra 29, which, what did I do with it? And I found out that the PLL on the Cobra 29 is absolutely for shit. I mean, like, as far as noise, absolute for shit. And this crazy ass contraption right here, just to put this in perspective, this crazy ass contraption comes out to about 70 dBc at 1 kilohertz or something like that. The Cobra 29 came in at like 40 or something crazy like that. Hang on, I actually have it here. No, I'm sorry, 77.909 dBc per hertz at 1 kilohertz. And the Cobra 29 was, where is it? 41.931. I have a picture of it here. Maybe that will work. Ooh, you can see the reflection. You probably can't see that picture, but I took a picture of the screen. You probably can't see that, but this is the phase noise plot of this PLL right here underneath my hand. Where's the 25? That's the 25. That first number, 41.931 dBc per hertz at 1 kilohertz. Absolutely for shit. I mean, I was surprised, like, how horrible the PLL in the Cobra 29 is versus this thing on a breadboard. It's just like, you've got to be kidding me. And I checked it and checked it again and checked it again and checked it again, and this freaking crude ass PLL on a breadboard, VPLL and VCO here on a breadboard, is better than one in the radio. It's just like, how is that possible? So anyway, guys, while I'm at it, before I hang it up, since I don't have a whole lot going on, questions at all about anything while I'm here, and hopefully I have it to show or to answer. Because it's I don't know, getting on for 10 p.m. for you guys, and getting on for 2200 for us, of those who use that time. Anyway, what else have I got around here to do? I've gotten a bunch of stuff here and there over the last few weeks that I've been busy. Getting less and less busy and more caught up, so sort of less of an issue. I was doing some ultrasonic cleaning testing and found out that neither Cobra 29 LTED Classic PLL, the tried and true, absolutely horrible performance. I mean, can't. I haven't even tried the LX, but it's basically the same phase lock loop, so I would imagine that it's probably not too dissimilar. In fact, that radio is still around here, and I occasionally pull it out and hack at it. It might actually be under the table here. It is. There it is right there. Complete with my wiring harness right here. The thing that I take and stick into the breadboard and hack at the display. I've already got this display all mapped out. I've got a library and code and everything for this display. It's just that what I was doing with this is the only way I could intercept this and process this reliably, the data stream that's coming across here, is with an FPGA, because I can clock it high enough and I can interrupt it high enough or fast enough to actually take the data, process the data, and spit the data back out onto the bus to keep things in sync. Because that's kind of the problem, is that this radio is constantly pinging the display. So you have to send the packets, you have to pass the packets back and forth. Because if you don't, then the display will just go all weird. So keeping the data in sync is actually quite difficult. You cannot do it with a microcontroller. It doesn't happen fast enough. Microcontroller can't process it quick enough. And I tried with a 32 megahertz ATmega. It's just not fast enough to do 2 interrupts, process the packet, to alter the display data, and then transmit that along. It's just not fast enough. But I was successful with an FPGA. But the problem with this is nobody's going to put a Spartan 6 inside of a damn Cobra 29. You know what I mean? I've got FPGA dev boards that I use all the time here, the Digilent boards. I've got a few of them, and incidentally, I have no blasted idea what I've done with those boards. They're not here. They're probably in a box somewhere. But I couldn't process the data with a microcontroller. It's just not fast enough to grab the packet. The fastest that I can, or the most that I could really do with a microcontroller with this is grab the data and retransmit it. That would work fast enough. But the instant that I tried to process it, so now I'm grabbing the packet and I'm trying to read it to figure out what kind of a packet it is, because there are different kinds of packets that are going to and from the display module. You got command packets and you have data packets. So if it's a command packet, you have to, because a command packet will set something up like, say, what column you are on the display. So, you know, you send a command packet, oh, I'm on column 2, row 5. And the data byte that gets sent afterward will get written to that particular position. So you have to monitor to figure out what type of a packet it is. Once you determine that it's a data or a command packet, then you have to obviously do whatever you're going to do with it, either pass it through or alter it. So it's really just a pain in the ass. And so that's why I didn't really bother doing any kind of really, you know, serious mods to this, because it's just, you know, nobody's going to use a $50-60 to buy a board that has a $50-60 FPGA on it for an AM radio. You know, I mean, because I could make it with an FPGA. I have a prototype, which I was looking around for it. All I do is plug these cables in and I can do what I want with it. But in order to make a board to fit this radio, it will be like a $150 bloody board. It's just not worth it for this. And it's mostly tied up in costs with the FPGA. Because, you know, micro just doesn't have the grunt. I might be able to do, and incidentally, before somebody, because I know somebody's going to say it, oh, but DMA, that was with DMA, so yeah, it's just not fast enough. I might try a PIC 32, because I can get PIC 32, some PIC 32s around here. In fact, I think I've got some here in the box. I can probably clock those up 80, 90 megahertz, and that might, you know, do it. Because the whole issue is not grabbing the data, it's processing the packet. So, you know, and changing it. So, because you have to grab it, okay, somebody changed the channel. So you have to grab the data packet, figure out what channel it thinks you're doing, and then, you know, interpret that. Like, if I was to switch out this PLL, which, you know, case in point, it's the same PLL as, you know, this, you know, which is already done, you know. Cobra 29 with, you know, 200 some odd channels. People ask me about this radio, but it's a test radio. Yeah, it works. I've used it in a car, AM only. Yeah, the coverage is like 26 to 28 megahertz or some crap like that. It's just, you know, 200, 250 channels on a Cobra 29. It's some, you know, somewhat ridiculous. So it's more of a toy. Anyway, so yeah, I had that one. I had another one here because I was doing phase noise measurements. But this is, you know, these things are identical. You know, I mean, they're identical. The old 29 and the new 29LX are virtually the same main board. Just, you know, with a refreshed front panel. You know, but yeah, it's basically the same. So, anywho, what else, guys? Anything going on? You guys tell me. Anything interesting happening? What I miss? I don't know how many of you guys watch the Radio Shop, see all that wonderful stuff he got from his benefactor. A spectrum analyzer, a scope, and I think an RF generator, I think, if I remember correctly. I can't recall. Nice stuff though. Anyway, so is this thing even still working? Because nobody's saying much. According to this, it is. So anyway, I'm not sure what else, guys. It's just getting on for, you know, 2200, and what else have I got around here? Oh, I'll probably have some to the 2000. The 2000. The 2000. You mean the 2000? That's what this is for. This is for the 2000. The PLL O2A. Right there. Same board. Yes. O2A. O2A, A58, 8719, 145, 106. PLL 2002. Bloody hell. BU 2630. Oh, what is that other one? A lot of serial PLLs are controllable with this. But the problem with the serial PLLs is that they are in radios like 2950s and Bearcat SSB 980s. One of them is a Crack Shack radio, which I know is around here somewhere because I put eyes on it earlier when I was moving radios around. Where is that piece of rubbish radio? I don't know. I have so many that I don't know. Those are parts radios, so that's not it. I still have crap all over the place. But yes, controllable. Is this it? This is it right here. For those who don't know what the BU 2630 is, that's the BU 2630 right there. That little guy right there. Yes. Oh, the 2000 with the 4. No. That was never intended to be for a 2000. That was intended to be for something even more special. For those who don't know what he means by the 4D display, that's this. One of these right here. Made in Australia. But yeah, I am doing a website. I actually have a very rudimentary thing that I have. I'm not a web developer, guys. I know a whole crapload of programming languages, and I mean what I mean by crapload of programming languages. I know a mega shit ton of programming languages, HTML being one of them, but I don't have the RT touch. But I will put the address here in the chat. It is formally and still is my company's name. So, yes, that is it right there. The 4D display, it has to go in a bigger box than a 2000. A 2000 will never accommodate that. The 2000 will accommodate this because this board right here was for the 2000. This was the prototype board. As many people probably recall seeing, that's what these buttons are here for, because these were the 3 buttons that were along the side of the Cobra 2000. So that's what this was for. No worries, boss. Anytime. So yeah, that's side incidentally, guys. That's what I'm sort of, when I get time, I start putting little bits up. I haven't done anything in probably about a week because of this building this bench and work stuff and you know, just busy. What else is new? So Yeah. So anyway, like I was saying about PLLs, bunch of serial PLLs, incidentally, like this one. This is the BU2630 to dually. This is a absolute horrendous piece of junk radio. No. Yes. Incidentally, when you say for replacing the speaker, sort of like a Washington. Okay, so here's a Washington. Okay. I never really thought about, I think I have thought about it, but we'll get the display out and we'll look. It would not really fit because, yeah, you see the issue with it. This is, well, the bezel, the display without the bezel, maybe you'd have to make a new bezel, but this is the frame of the LCD. You can see the back of the speaker there. Yeah, maybe. It might work. That would be a hell of a mod, though. You'd have to get a speaker, an external speaker for the radio at that point. I don't know how miffed people would be about that, but it would probably work. I've got the smaller one. This is probably just too much of a baby. I wonder if there's one in between. Yeah, see, that's too much of a baby. You know? That's too... you know, it's sort of like... I wonder if there's one in between this one. I'd have to look. This is a 2.4 and Blunkunk, and this is a where's the label? It's like a 4-inch, 4.3, I think. Yeah, 4.3. So this is 4.3, and this was 2.4. So yeah, it would take some sort of hackage to put something in this area. But yeah, it probably would work. Just answering text messages. So yeah, they might have a bad in between, bad mic cord. What do you mean? Blunk blunk. Audio's cutting out. Entirely possible because, you know, things are all ajar. So anyways, yeah. If they have something in between, yeah, you cut that out. I think this is, yeah, it's got one blasted screw in holding it in. So, but yeah, that's the back there with the speaker. You just rip the speaker out, and yeah, you could probably fit it in there. If they got something in between, I'd have to look at the list. Incidentally, the guys at 4D Systems in Australia are really nice people. I like them. Very helpful people. So, yeah. That's a very good thing. So, cut something, click. It could be because I've got one. You know, I'm knocking around and bouncing into things, so it's very possible that that's what happened. I probably knocked into something. Not to mention I was moving radios around, and so what else have I got over here? Next question, and I'll pull out whatever people ask me to if I can find it. That's the key, if I can find it, because I still have piles of, I mean, just shit all over the place. Trust me when I tell you, it's a mess. So I'm waiting for one more piece of gear that I'll have tomorrow. What I'll probably do tomorrow, guys, if you guys are around tomorrow, I get the new Siglent spectrum analyzer, and so I'll probably fire it up and go over the Siglent spectrum analyzer if anybody's interested in seeing that. I should have it tomorrow. So says the post. So you know, the whole signature required deal, because you know it's a expensive item. So I should have that to fiddle with. So if anybody's interested in knowing my opinion of a Siglent spectrum analyzer, by all means, that'll be a tomorrow thing, except everybody's already done reviews and discussions about it, so I don't think I can really contribute much to it, because Dave Jones has already torn it down. 980 SSB. I'm thinking about doing something with a 980 SSB, yes. If I can pull it off. The 980 SSB, I can tune that PLL to wherever in the hell I want. It's just a matter of writing code, and I've already shown that. The 980 SSB that I have, I'm just putting stuff away, guys, while I yap, so don't mind me. Because, you know, I got lots of cleaning to do yet. But the 980 SSB, BU2630 PLL, widescreen. What do you mean by that, Santos, when you say I need widescreen? It's actually pretty wide. Like, this is like several feet of space here. Actually, I could raise the camera, but then you wouldn't see the bench. You'd see the bench, you'd see the floor, you'd see the shelves this way, which is like, this is the bottom of the shelves right here. Yeah, the 980 isn't anything special, guys. I mean, really, it's a serially controlled PLL that if you write about 200 lines of code, you can make it do what you want. The real magic to that is soon to come. That one I think people will be intrigued with. I've caught a lot of shit over the 980. Like, really, guys, like a lot of shit. I've gotten emails out the ass over the 980. It's just, the controversy over that is insane. Like, the whole amplifier fiasco was like, that solicited about 30, 40 emails. I'm not exaggerating. I mean, if I went and started pulling them up about people who were saying, so-and-so said it doesn't work. I had like 5 people email me that 5 different people said it wouldn't work. So it's an amplifier. Why won't it work? I mean, it's an amplifier. There's nothing special. It either works or it doesn't. And yeah, it's just... this camera, incidentally, is the same camera I had before. It is a Logitech... what is this thing? C130? I think. Let me find out what the computer says it is. It's somewhere in here. Where is it? Incidentally, did it freeze up the video? No, it didn't. C930E is the camera. 930E. I'm just stuffing this into Google so that I can link. Here it is right here. This is the camera. So I don't have a new one. This is the one I had before. But this is the camera that I'm using now. I was using it before. I think the lighting was different. Just the location was different. This mat looks funny in this camera right now. It doesn't look like it's the same color, for example. I need to work out color issues because it's not the same color. This is a ESD mat. It is, I don't know what color or shade of blue. A lot of you guys might have these Menda bottles, and you can see the color's pretty close. To me, they look almost identical, but on the screen they don't for some reason. So if you have one of these blue Menda bottles, it's pretty close to this. But for some reason, it just doesn't look the same. I don't know. It's a setting, something with the camera. I need to do some settings changes or something like that. It might be lights that are the issue. So I've got a light bouncing off the ceiling. Because if I bounce it down at the bench, like, you see how bright it makes things? And then you have shadows and all that. But that makes me look really blasted pale. Canadian seller. Let me find it for you. Because, in fact, I got them off of Fleabay. It's the real deal. I mean, you can buy it from DigiKey, or you can buy it from these guys that sell them on eBay. So let me get you a listing here, and so I can show you what I got. That is the mat right here. You know, it's the real deal. If I measure it, it's dissipative on the bottom, I think. Yeah, see? So when you flip it up, you know, the black stuff on the bottom is the dissipative portion of it. Someone actually, when I was talking to him, I was talking about all the ESD gloves that I found that I had in this room. Like, I've got tons of ESD gloves as well. You never see me wear ESD gloves because I don't wear ESD gloves. But for those who don't know, this is a pair of ESD gloves. This is what they look like. They actually don't look right on the camera. They look like they're flaked with black stuff. In reality, you can almost, yeah, you can kind of see it. Well, they're giving me a hard time because they don't believe that the 980 could be used, the new model 980 that could be used with an amplifier. People still don't believe that. I get emails about it. But you can see ESD gloves. Yes, they read. So, you know, they've got some kind of impregnated resistive stuff in them. I've got several pairs of them. I never use them. It's just, you know, most of them don't fit me anyway. Like, you know, I put this on and it's sort of like, you know, it doesn't really fit. They don't really fit my hand. Like, none of the sizes of these things fit my hand very well. Like, they don't go back to the fingers are too short. And you see, like, I've got, like, you know, doesn't go all the way down. You know, I'm sort of like O.J. Simpson trying to put on these gloves. None of them fit. I've got many pairs of them. I think they would fit my wife better than they would fit me. My hands are just too big, so I don't wear them. Not to mention, I don't think they're really very effective. I know people who do, though. They wear them. It's like, nah, I don't bother with ESD gloves. Anyways, the 980 is, it just seems to be like one of those imagination projects for people. You know, because like I've got a 980 here. You know, it's a unopened new 980 that used to sit up on the other bench, and I just haven't put it here yet. And it used to just sit up on a shelf, and I used it for a listening radio. And so that's what this was, because you can listen on this radio without a microphone. And it would just sit up there with a couple of pencils, incidentally, a couple of pencils under it, so that so that the speaker wasn't covered up. Because I just, you know, I just listen. I don't really talk. But, you know, of course it's got the encoder that's sort of iffy like everybody else's encoder. But I think this is an old Rev 980, because the new ones have a different FCC ID, as I understand. The new ones, I'm trying to remember what it is about them. The 980 SSB has a different number, the new Rev on the back, and that's how you know without opening it. This one's definitely an older one, which they say works with the Stinger, but the new one doesn't, and I can tell you that they both work. But apparently there's some yo-yos who believe that it doesn't, and I never understood that. It's just like, no, it works, you know. Open it up to be sure. I never opened this radio, so no reason to open it, because it's just a radio that's up here on the bench that I used for listening, like I said. But yeah, they don't believe it'll work, and I know it works. I had a video, you know, several weeks back, and yeah, that video generated a lot of damn emails. Still does. I have several a week. Oh, well, so-and-so said it doesn't work. Okay. Why? Yeah, this is an old revision 980. You can tell by the auto expander and the fact that there is a tunable receiver, because on the new one, this is all fixed. The SWR bridge is on the bottom. You know, it's a much cleaner design than this. This is definitely our original 980. So, which is pretty much what I expected to find. So I just need to get a couple more of these for sacrificial lambs. Well, yeah, basically. So the 980, and guys, an amplifier is an amplifier. It's either going to work or it's not going to work. And I keep getting emails about it, but so-and-so said you can't put the Stinger in it. Okay, why? I mean, nobody's actually come back to me with like real concrete evidence that it doesn't work. It's an amplifier. So you get noise in the VCO. You get a warble. Shield it. Move on. You know, it works fine. You just shield the blasted thing. It's an amplifier. You put an amplifier inside of a metal box. Shield the VCO. Move on. It works fine. Better option would be to shield the amplifier itself. Maybe some low-pass filtering. But then again, that's crazy talk in CB world. Low-pass filters? Why would we do that? I mean, no. We don't want to put low-pass filters on our amplifiers. That would be blasphemy. So, oh my. So, anyways, what else have I got going on in here? I don't think I have much, guys. I really don't. I think I'm pretty much all washed out, except for tomorrow. I'll go over that spectrum analyzer, you know, and that's basically it. Nothing else going on. Not in my world. I'm almost done with my bench, you know, business, and hopefully I can do some videos of the, like I said, of the PLL, signal analyzer, and you know, talk about phase noise in phase lock loops, and why phase noise is a bad thing. You know, like the Cobra 29, which that still blows my mind. The Cobra 29 is such bad phase noise. It's an AM radio. I guess people would never notice it. It's probably passes barely. Anyway, guys, questions, comments, something I can answer for a Sunday night before I call it a night. Trying to think of what else have I got going on. Like I said, it's been rather dull and drab, other than building boards, which I was doing earlier so that I can send some nice people some boards. I'm just looking through my Fleabay list. What have I got coming? Nothing very interesting. New GPIB cable, because I got a bad GPIB cable. For those who don't know what a GPIB cable is, this is a GPIB cable. I got a bad one. Flaky. How about the carrier frequency wobble issue with the modulation envelope? I don't know if it will measure. That's not going to measure that one. Yeah, it's not going to measure that one. Yeah. It will do FM deviation. But anyway, yeah, this is GPIB cable. And something's flaky about this. Not too sure what. I was getting a lot of comms errors with the instruments connected to this cable. So yeah, I got another one coming. See, these things are ancient. I've had these things for practically forever. They even still say HP on them. You know, none of that. None of this Agilent or Keysight nonsense. This is a real HP cable right here. So anyway, they're meant to be daisy chained for those who are not familiar with GPIB. Basically, they just, you know, connect together as such, and you keep stacking them up. So this would plug into an instrument. The cable would plug into this. This will go to another instrument. Another one would plug into this. And you chain them up to, I think it's 30 devices on GPIB. So, yeah, is there a date code in this cable? No. Forget how many conductor cable this is. I don't think that's a date code on it, though. It says 12/15/82. Well, it's entirely possible that that is like a date of the date that the thing was, you know, put together. Probably read that one better. I'm pretty sure that's not a date code, but it would probably be about right, actually. So I'm not too sure what's wrong with this cable. If it was an issue with the end or something like that, where maybe if it got bent a certain way that it would be flaky, and I don't think it's a connector. So it's a cable. I was going to tear the cable apart and figure out. You know, the problem is that it's a shit pile of conductors to. I've actually never taken one of these apart. I actually don't know what's in these. I've never had a reason to take these apart because these are fairly expensive cables. So I really don't bother to take these things apart. But, you know, they screw into each other and everything. So, you know, I just go to eBay, buy another cable. Don't go to Agilent to buy, or Keysight to buy these damn things, or National Instruments. It's just too bloody expensive. I think that they'll charge you for this cable. This is what, one meter ish. You know, will probably charge you, you know, $100 for this wire. You can buy it on eBay for like 15 bucks. You know, and this has obviously been around the horn. It's kind of dirty. But you know, so these cables basically, they go between the instruments. The instruments all talk to each other over this bus. For example, the 4352B controls my Marconi 2030, and it sets its frequency, its output level, and all other wonderful stuff. Basically, the parameters for the signal generator, because its reference, its local oscillator, and its reference comes from the 2030, and so it controls it over this GPIB, and sets frequency and so on and so forth, whatever the thing needs for whatever you're doing. And then from there it goes to another instrument, ends up at a computer. And when it ends up at the computer, it goes through one of the two things. I actually have a GPIB card in my computer. In this computer that's actually on this bench right now. On the other bench I didn't have it because the computer with the card was here, or at least where what was used to be where this was. So I didn't bother because it's across the room. So, and I didn't bother to move the card because there's no free slots in the other computer and so on and so forth. Incidentally, that other computer's sitting over there on the floor. Yeah, that other computer that's flaky, I actually fixed it. Because you guys might remember that the computer used to lock up. And so, let's see if I can get at it here. Yep. So, here's the computer that was locking up right here. You know, there's my keyboard thing still plugged into it. So this is the computer that used to lock up. As you can see, it is wireless. And they wouldn't ship it to Aussie? No, well, you know, you might ask Peter on EEV blog. You got a lot of Aussies there. Dave Jones mentioned where he got his from. It's a good price for the mat. In fact, the person who told me about it was Mike, about that seller on eBay. Because otherwise I'd have just bought it from DigiKey and I would have probably, you know, lost a bunch of coins. Anyways, here's the insides of this computer. As you can see, it's got a big honking video card in it. And this computer was locking up because of this power supply. Well, the power supply that was in here was the problem. I switched out the power supply and this computer no longer locks up. So it's rather unfortunate that, it's not going to be doing the stream anymore. So, yeah, it's just a spare computer around here now. To add with the other two that are sitting over there that are spare computers. I guess I could have put the GPIB card in here, right here, because there is actually a slot here. But the problem with that was it would have blocked the fans in the video card here. You know, because this just doesn't have any room to put the GPIB card. It is a PCI Express card, so it goes right into the slot down in here. It would fit in there, but it's about so long, so it would just block up the fan, the air inlets. That wireless card is actually partially blocking it, but there's a second fan over here, and so, you know, this was the computer that I was using for the stream on the other bench, and now it's just a spare, I think it's an i5, Intel i5 machine, you know, Windows 10 and all that wonderful stuff. So it's just a spare box if I can get that blasted lid on. So, yep, that's it. Not a whole else going on. Anything else, guys? Anything I haven't covered? Anything I haven't shown? Anything I haven't talked about? Questions, comments, flames. If you're gonna flame, be gentle. Be gentle. I suppose that belongs over here. Anyways, let's see what else I got on my Fleet Bay list that I'm expecting. Got all that stuff. Those encoders. I'm not sure what I did with them, but I had gotten these wireless modules. No worries, man. It's I don't know when I'll try to get to it. I'll try to do it afternoon-ish, Eastern, because it's a Monday and I can't really, you know, I gotta be somewhere. I gotta do stuff on Tuesdays. I can't really do a whole lot of late night stuff tomorrow night, but I'll try to do it. And you know, you'll get to see it one way or another. YouTube records it. It's just no big of a deal. What's interesting about the spectrum analyzer is that a DAC-10 launched in a trebuchet arm. I don't know, man. Is it a DAC-10 that's intact? I would actually might want the radio if it was a DAC-10 that was intact. I think Mike had a bunch of them. Well, I guess while it's sitting here, I can talk about ultrasonic cleaners. I got this cheap ultrasonic cleaner. Cheap thing. Okay. There's the lid. Nothing fancy, nothing special. There's the basket. Nothing fancy, nothing special. There's the cleaner. Nothing special. That's the front. Works very well. Not as good as the one that I have access to, which is a ginormous, sits on wheels on the floor, but for me around here, this is just fine. And it's loud. It's an ultrasonic cleaner. They're loud. I haven't bothered to take it apart. I actually used it, and I've been actually meaning to open this thing up to see what kind of bad Chinese wiring we have in here. So maybe I'll give that a go right quick while I'm thinking about it. And then when I see the bad Chinese wiring, I won't want to plug it in anymore. Yeah, this should be it. I don't know about these ones. They don't look like it. But we'll find out. Let's look at some Chinese wiring. This ought to be entertaining. Probably hot snot all over the place, and Chinese love hot snot. And bodges. Okay, so there's actually something there. Oh, the circuit board is there. Actually, that's not as scary as I thought it was going to be. I mean, there's your hot snot. But I was actually going to, I was more afraid. It's not terrible. It really isn't terrible. I mean, it's really not. I mean, no, that's not bad. Can I get this board unplugged? Okay, so that's going to be the ultrasonic bit here. Right here. This is going to be the ultrasonic bit. This is going in here. This thing here must be the transducer. Yeah, that's the transducer right there. It's sort of like welded or something, somehow affixed to the metal dish inside, to the basin. So see if I can get this board out. Oh, these are locking lugs. It's fused. There's not, it doesn't, I mean, it's not that scary. I thought it was going to be a lot worse than this. This is actually not terrible. Let's see. What's up with the mains back here? It's got a fused mains plug. So, yeah, this is fused, so you know, this is Chinese stuff. You typically don't get this, you know, fusing of bits. And, you know, they've obviously fused the mains. This is a 10 amp. I don't know about that. 70 watts? No, I don't know about 10 amps. That just sounds suspect as all hell. You know. That's, yeah, that's dodgy. Then again, it might not be a real... Oh, you know what? They actually have included... Look at this. If I can get it out, a spare fuse in there. And it's a 10 amp. I don't know. I mean... I don't think this thing needs a 10 amp fuse. I think that's the dodgy bit right there. The 10 amp part. I don't buy the 10 amps. Although the wiring up to this thing is heavier wire. This is actually pretty heavy stuff. So maybe so. So let's see if we can't get a good look at this board. It's not terrible. I mean, it really isn't terrible. It's got some JWCO caps. You know, I mean, it's got some cheap Chinese caps on it. But we've got all kinds of, you know, we've got relays here. We've got, where's our mains come in? We've got, this looks like a common mode filter. Yeah, because we got a bridge rectifier and the caps and all that kind of stuff. So this is a, you know, without getting the board out because it's just bolted. And we'll pull this thing all to bits. Get the hot snot that's sort of just coming out of it anyway. But no, this isn't terrible. So we've got this low voltage cable that goes up to the front panel, and the front panel is obviously it's bolted to the front, but I don't see what they've got in there. It must be a microcontroller or something up on the front panel, because it's not on the back, so it's probably on the other side of the board. You got some fairly big chunky tracks on there as well, and I can't see why. We've got these two wires here. This is going to be for the thermal sensing for the that might be the heat. No, that's going to be the heater. It has a very small heater in it, but this is going to be the heater right here. So this is the heater, and probably the case with the fuse. And this is the thermocouple here to do the heat sensing. It goes up to the front. So everything that's happening is going to be happening on the front. You got relays. These relays are rated 10 amps. 10 amps, 250 volts AC, 10 amps, 30 volts DC. What's the coil voltage is a 5 volt coil. So this might be a, let's see if I can shine some light on the situation here and see what this is. I bet it's probably a 7805. L7805 CV. I called it. 5 volt relays, 5 volt voltage regulator. It does not heat sinks, and I would imagine it doesn't need to be, because it's not really doing a whole lot. We got a full wave bridge there. We've got another full wave bridge there. We've got these two Fujitsu looking parts down here. I can see the logos. They're Fujitsu parts. Those are FETs. Those are probably driving the transducer. These transformers. You see this ring of capacitors and things in here. This is probably driving. Clearly, this is driving the transducer. So you see, we've got. They actually tried to, do some kind of reasonably good job with ventilation. You see holes in the circuit board to allow some convection cooling of the heat sinks. So they actually, maybe thought about this a little bit. And these relays are clearly, this is just for the heater and for the ultrasonics. So it's probably just a click kind of thing, click, turn it on. I used this thing only once. So, and it did a good job, actually. I mean, but, I've used big industrial ultrasonic cleaners, so, I mean, it helps to actually know, how to use them and how to set up the solution. Yeah, I'm not going to pull the control board apart. I was thinking about it. For those who don't know, you use something like this for ultrasonic cleaning. Yeah. You mix up according to the instructions. And you drop your board into it. Interestingly enough, I had a very nasty side effect with this. This is one of the things that I'm probably going to look at right quick, actually, before I close this up. When I dropped a board into this, it was a tested working board, okay? And it scrambled it, like, literally. So I did a test. So, okay, I'm going to clean a board, and it scrambled the board. It scrambled EEPROM contents. It didn't boot anymore. And I was like, okay, what happened? My first thought was, because it acted dead, my first thought was, oh, well, some component or something somewhere on the board that I use. And mind you, okay, that board is, where is it? It was my test board, actually. This one here is my test board. Okay, see, I have the mounting already on this, and I have these big sort of chunky tack switches to make this easy to to work with, and all these connectors and whatnot. And you see I have just a pin header on here. This is basically a test board. And so I dropped this into it, and so it cleaned it up really well. I mean, it's nice and clean. You could see it's shiny and mirror image. I mean, it cleaned it very well, but it scrambled the bloody hell out of the thing. And so it didn't boot anymore. And I said, okay, well, what the hell happened? And my first thought was, oh, the bond wires and the micro. But then it's like, well, it's a plastic package. It's rated for this. Maybe the display driver. The display driver's datasheet didn't say anything into it. So I contacted the company, the Austrian Microsystems that make the display driver, and I contacted them and said, hey, is the display driver safe for ultrasonic cleaning? And they said, yeah, it's fine. The TI part that's down here, yeah, safe for ultrasonic cleaning. I mean, the rest of it's just 0805 SOT23, components. I was like, okay, maybe the crystal. But crystal's made by Fox. And so, again, no problems with any of the components on here for ultrasonic cleaning, because that's an issue with these things is ultrasonic cleaning. If the components, certain components, you could just bust the bond wires off inside, ultrasonic clean them. And so I was like, okay, I certainly did that. But I was like, okay, so the board's dead. So unlike production boards, I have a JTAG header on the board here. That's what this connector here is. So I was able to JTAG into it, and I was able to, okay, so what's the problem? And then I read back the EEPROM contents, and the EEPROM contents were just random, just junk. You know, flash memory was just junk. And I didn't get it at all. So my first thought was, okay, well, what could possibly have happened in the ultrasonic cleaner to cause this thing to go? And I reflashed, it's fine. You know, that's the whole thing. So it's like some kind of electrical discharge through the board. I don't know. I mean, it's a test board. I don't care. But it's fine now, you know. So I was wondering if, in some way, shape, or form, which is what I was going to look at before I put this together, is this thing somehow making contact with the basin, and are we getting a charge induced into the solution, which, you know, is just distilled water, you know, but who knows, you know, what else is going on. It's just weird and unexplained, and I have no earthly idea what happened to cause that to go on. And so I'm not putting any more things in this until I can explain why this happens. Incidentally, I talked to Mike about it, and the basket, okay, I mean, literally, you know, drop it in, put it in the cleaner. And so, you know, just don't know what could possibly have gone wrong with this thing. So I was wondering if any of these connections between the ultrasonic cleaner and the frame, you know, because this whole thing is just sort of all like welded together, if there's any sort of you know, connection going on, which doesn't appear to be, you know, and it would have to be, you know, I would think from the ultrasonics, you know, because we've got this serious, you know, current and high frequency stuff going on here. So I don't know. I mean, that's connected, but not to the chassis. You know, it's isolated, and I could see that it would be isolated because there's a like a rubber, plastic, or spacer in there between the coil and the basin. So, you know, there's that ring in there. That's definitely a rubber feeling stuff. So I don't know. I'm at a loss. So the only thing I can do is put it together and try doing experiments. But other than that, I'm actually okay with the way that this is built. This isn't terrible. I mean, you know, at all. I mean, this really isn't terrible. This could have been worse as far as build quality, but this is actually not terrible. So you know, it looks like there was another potential option for this board. This board, incidentally, has a date code of 2016-1105 on it. We got a couple fuses on the board itself. Well, you know what? That's interesting because there's a fuse right here off the mains input. So we've got a little fuse down here. So the 10 amp fuse up here is sort of, I guess we're just fusing the plug and the switch for no other reason other than to fuse the plug and the switch. But the board actually has another fuse on it. So, okay. I guess, you know, idle 2600 there is correct. Yeah, but honestly, not being a mechanical engineer, I wouldn't know. I don't know what the frequency of this is. Unless it's written back here somewhere, which I don't see. I don't honestly know. Yeah, I don't honestly know. What I do know is that it just scrambled the EEPROM contents of a microcontroller. Beats me. It is the strangest. I don't know. And the thing about it is, I need to do another test for the simple reason that, for all I know, I scrambled the damn EEPROM contents of that thing myself, screwing around before I decided to drop it into this thing. Because I honestly didn't plug the stupid thing in before I dropped it into this thing. So for all I know, the damn thing was scrambled before I put it in. So I need to do it again, but like, you know, make sure it's working. And what I might actually do as an experiment is power the damn thing up and have it swimming in the solution when I'm ultrasonically cleaning it, and find out at what point it dies. So if this is the board in the cleaner, okay, if I could sort of hover it in the solution or something. That's the other thing is I just put it in the basket, dropped it in, you know, in the solution, which fills up to about, say, here. So it comes up to about, you know, here on the basket, about halfway up the basket. And the basket doesn't get to the bottom. The basket's about, that far from the bottom, which is, you know, that's not easy to quantify. 2 centimeters from the bottom. So, you know, this thing is just sitting in the solution in the basket, and, you know, so, you know, and that's the thing. When I drop this in, it's quite fascinating because I've always been, having used ultrasonic cleaners a lot in the past, and still using them, but using the much larger ultrasonic cleaners. When you drop your board in, you always see the gunk, the flux and everything, because, you know, there's flux that gets underneath the integrated circuits, and you always sort of see this haze just sort of billowing out of the around the pins of the packages. It's actually quite fascinating to watch. You just see it billowing out of the from underneath the ICs and other largish components. Mostly the ICs. You know, maybe a pin header like this one, you might see it sort of coming out from around it, but usually it's the these SOT packages and whatnot that, or these quad flat packs that you see the sort of haze coming out of from around them, and that's of course the fluid cavitating all around and you know, bringing that gunk out and around these connectors, because you know, they tend to get flux and whatnot from underneath, you know, underneath them. It's really hard to clean that stuff out. But with this, I mean, it's remarkable as to how effective it is. So that's why I really want to, you know, figure out why this thing went nuts. If it even did, it could be, like I said, totally me. I scrambled it before I dropped it in there, and then I pulled it out, cleaned it off, heated it up to dry it. Yeah, for all I know, it was my problem. I did it, and I had it scrambled up before I even dropped it in there, and so I was just expecting to plug it in and have it work, and of course it was already scrambled up from whatever test I was doing, and you know, it just didn't work. So incidentally, does it work right now? So the way I can find that out is simply to plug it in, and hopefully it doesn't screw up the camera because I'm plugging it into the same bus as the camera. Yeah, it works. So I got a flaky cable on this. Let's see if I can. Yeah, see, it went nuts. I've got something running on this that just made it go completely nuts. So we'll try this again, and Yeah, it's flaky. Whatever code I've got running on here is flaky. It's a test program I got running on here, and it's something's wrong with this board, I think. Yeah, something's wrong with this board. Yeah, see, I made the digit go out. Something's wrong with my test board. See the digits flashing, the top on the 3. I gotta fix this board. It's no good when your test jig is is hosed. So a candidate in the jar for the journal, yes, exactly. Except this has got a I think the cable, and this is the cable is probably just for me pulling it, you know, like that, pulling it in and out, in and out, in and out, and I've fatigued the cable, and that's probably why the encoder's now gone weird. Yeah, the encoder's off this same cable. Yeah, the cable is bad, so if I borrow the cable from the binary, because all these LEDs are showing me is the binary pattern that's going to be transmitted to the phase lock loop. So yeah, there we go. So of course it's behaving a lot better now. So those are all encodes. It's done. So yeah, let's see if that's gonna, nope. So it's the cable. It's just the cable. You know, one of those things. That's probably just from me tugging on it all the time. I mean, in fact, it looks like I can even see it right there. Yeah. Yeah, it's just me tugging on it, you know. It's not going to handle, you know, much, you know, insertions and removals. So, you know, it's not made for constantly being plugged in and unplugged. So those cables will just go in the bin, and I'll just make another set. So the only thing I can't see right now, of course, you know, is it'll be the same problem with this. Or no, because it's probably a different lead that's not going in and out right now. There, yeah, see that one just appeared and it went out? Yeah. So yeah, it's this end, it looks like. Yeah, it's this end right here. That end of it's bad right here. And I could probably just cut this and put another connector just further up the cable and keep using it, but you can see that one bit is just in and out. So let's go to however many bits this is, 511. So there we go. That's all of them illuminated. That one bit's going out. The incidentally the very first bit. So yeah, bad cable, but board's fine. Just gotta change my cable out. So yeah. Anyways, I figured maybe it was you know, test software, because there's probably a test build on here, and I figured that maybe that was what was causing the flakiness, but no, it's just this cable. So let's just chuck it away now. Where's the bin? There you go. Landed right in the bin too. Say sayonara to that cable, and yep, easy problem to fix. Just these cables on these things. I'm constantly pulling them, you know, the other ends in and out of boards, because when I'm building the boards, you know, obviously the the way that these are tested is USB. They get flashed. They will power off of, obviously, power from USB as well. You know, and it's got switching on the board that handles, you know, USB power and onboard power. The second thing that happens is, you know, because they don't have connectors at that point, because the connectors I don't put on until people tell me what they want. And so I just power it from DC input to make sure that the switching supply is working. You know, and that's after it's flashed, and then, okay, the switching supply is working. Then I literally take another radio with a socket in it that I test these with, and plug this into the socket, plug a cable into it, and make sure that the radio works, you know, and that's essentially the test process. So I've got a Grant over there with a socket that I just plug these in, and the thing about that is the sockets get worn out in the radio because I'm constantly pulling the boards in and out of it. So I have to change the socket. I've had to change it 3 or 4 times already. You know, because it gets flaky. So what happens is I put this in, it doesn't work right, or it just doesn't, you know, I just have weird problems. It's like, okay, time to change the socket. I should probably get a ZIF socket, you know, like you'd have for your EEPROM programmers, which I don't even know where my EEPROM programmers are. They haven't made it in here yet, out of boxes, and just get the ZIF socket so I can just plug it in and throw the handle. I probably should do that and put that in the radio, because the only way I really have to test these PLLs right now is to put it in a radio that is already aligned, and it should work, and I should get what I should expect from that particular radio, which is the top and the bottom channel, and they should lock just fine. You know, because there's really not going to be a whole lot of variation in the PLL chips. It's going to be the VCO in the radio. So, you know, I've never had, you know, if I go plug this in and I have the proper channel range, and I go and get another one, I plug that one in, and they just work. You know, so I've never had a PLL chip affect the lock range in a radio, at least from my observation. I've never had it happen. Now, I've had bad connections in the socket where it would work, but it would not be right, and then you go wiggle it, and then all of a sudden it would start working. You know, I've had that happen, but that's just connection issues in the sockets. So I should probably just get a ZIF socket and put it in there, and this way I have a little lever, and I don't really have connection problems. Not to mention the socket. You know, these things they fit in, and they've got these pins. You know, they're long, because when you guys put these in the radios, you put them in, and then you cut the pins off. You know, for the right height, whatever height you need, and then you cut the pins off. Exactly. So yeah, and since it's a test radio, I would honestly just drill the damn holes and make it work, because it's a test radio. I don't even know where that radio is, because these I have to test these, so I have to find that radio. VSR vibration starts with the Metalax. U.S. Department of Energy. What is it? What is Metalax? Vibration stress relief. Beats me. Not into the mechanical engineering aspects of things. I have people who do that, yeah. I just ask them, you know, hey, you figure that out. I'm sure I could probably figure out the math if I, you know, saw it, but yeah, other than that, it really isn't that interesting. So yeah, a ZIF socket. I probably just need to get one. I mean, I have other ZIF sockets. They're not going to fit though. like this, for example. You know, this is obviously a, you know, ginormous 40 pin zip socket. And yeah, the pins on these are definitely fatter pins. So, but I need to get a small, you know, 18 pin zip socket, and this should be, you know, fine, because then I can just, you know, do that, and that, you know, is fairly rigid, and then I can do the test, and then okay, I'm done, and, you know, pop the handle and move on. So I ought to find some, you know, 18 pin zip sockets that I can just put in the radio for testing, because I only need it for testing. You know, the radio is not going to be a road, you know, something that I'm going to use, you know, because it pretty much is the radio. I just come over here, plug a power cord into it, plug an antenna into it, plug a microphone into it, and plug a board into it. Like, it doesn't even make, these don't even make it in the radio. They're just sitting next to it, you know, cable going over to there, the display sitting there next to it, and, you know, I'm getting the power externally, and I've got a long harness that plugs into here from the radio, and so, you know, all the functions get tested. But you know, that's basically it. I wonder what I did with my grant from the car. I brought it in before I started working on this room, and mostly to get the new firmware. And I think that grant got lost in here, because it's my car radio. Yeah, I don't know. Maybe I took it back out to the car. I just don't remember. But yeah, another radio that, of course, I could test the boards in is this one, because it's pretty much just, you know, just that. But this is the 29. This is the 2816, 2824 board. That's a test prototype thing. You can see all of my wonderful bodge parts on the bottom, not my bodge cap, and all that wonderful stuff to alter loop filter on this, because this is still not perfected. It works, but it's not perfected yet. I need to get back to work on it. But I have used this radio. Yeah, it's a dud board too. So, anyways, let's see, used to have this lift sockets. Oh yes. No, I haven't seen those either. Not lift sockets. But yeah. And now that I brought this out, people are going to start asking me for this. But I want my Cobra 29 to have 250 channels. Maybe I'll list this one on eBay. It'll be the only one. And yeah, it works. It's just surprisingly well on top of it. Like, surprisingly well. Like, it will receive to damn near the full range decently. Like, I was quite shocked at how broadbanded this radio is. But the PLL on this thing is, the VCO is just, it's a complicated, you know, beast with the 512 kilohertz, 455 kilohertz, sorry, offsets, and just weird stuff, which is why we need this. We need to detect mic when the radio's transmit or receive, not only for the noise toys, but for to be able to do the offset, because the offsets, this is done in software. So you know, when we transmit, we send an encode, and when we receive, we send a different encode, so that we can do the transmit and receive offsets. So yeah, this is a board that has a bodge track somewhere bodged over here, you know, which is why it's all, you know, black markered and all that kind of wonderful stuff, because it's a, you know, a dud. But it's a dud in here for testing. So yeah. Other than that, yeah. Cobra 29 with 250 channels. Yeah, nothing special. Now that I brought it out, I'm going to get emails about it. I want a Cobra 29 with 250 channels in it. What for? It's an AM radio. You can't do much with it. Anyway, guys, it has been a fun little test tonight. I'm glad that my camera works mostly. I'll try to figure out the color issues, and I'll email some folks that are experts and say, hey, tell me how to fix this color. I'll take a picture of it with another camera, like on my phone, and say, this is the real color. Tell me why this camera up here shows a different color. Tell me what I need to do to fix it. So, yeah. And these, I got to make a board for these and actually try them. Really, you really got to bear down on these to turn them, which is nice, you know. So people want stiffer encoders, you know, they want a real detent. And for those of you who keep calling it an indent, it is not an indent, it is a detent. Detent. Got any people email me, oh, the indent. No, it's a detent. Detent with a D, D-T-N-T, detent. The indent is it's not that stiff. Oh yeah, because it's like this that has an encoder. You can just, you know, flick it, you know, and get damn near a turn and a half out of it, you know, by flicking it. So, you know, very easy to turn, but this same knob or encoder, I mean, yeah, I can flip it, but I'm not gonna, you know, get that rotation that I like out of the other one. Like, there's no way. So much stiffer encoders, much more expensive though. You know, I cannot stress this enough, guys. If you want one of these, first let me get the board made, because I gotta modify the existing board to be able to fit this footprint. Second, I got to make sure that my quadrature decoding library will work with these, and I don't think it's going to be an issue. You know, I highly doubt it. You know, it's a bloody quadrature encoder. I mean, you know, they're a piece of piss to decode. It's just a state machine. You know, the other thing is I just don't know how easily these are going to be able to adapt into a radio just because of their size. So give me a little bit of time before I want the stiffer encoder, because I know that's going to start. I want the stiffer one. I want the stiffer one. Yeah. I'm working on it. The button is pretty okay, you know. It definitely takes, I think, more force to... I think this button's easier to push, which I think is the problem here that I know I'm going to hear about. This button is easier to push than this button. Like, there's more force required to push this button than this one. You know, this one's really kind of loosey-goosey to push, but this one requires a lot more oomph. And so I think that that's going to be the trade-off. People are going to be like, but the button's easier to push now. Yeah, it's stiffer, but now when I'm changing the channel, I'm going to be pushing the button a whole lot easier. Yeah, I think I'm going to run into that's going to be the problem. It's just like, okay, you want a stiffer encoder, but the button's the button's easier to push. That's been my only observation really with those, is the button's easier to push. These ones are harder. So you can't really push it by accident too much, you know, like you gotta actually push the button. Whereas, you know, like flicking this, you know, I'm not pushing the button, but if I try to flick this, you know, I'm going to push the button, you know, it is going to happen. So yeah, trade-offs, man, trade-off. Anyway, guys, it's after 2300, so I'm going to call it a night. And tomorrow, what the hell is that damn thing called? The spectrum analyzer. What is it? The Siglent. What is that thing? What is the model number of that thing? Let me look it up really quick. I can type. I really can. It is the... Come on, Siglent page. Load up. SSA 3021X or SSA 3032X. I am getting the 3021, and depending on how froggy I'm feeling, I'll probably bust it open with the firmware. Yeah, you know how that goes. Some of you do, at least. Bust it open, bust the firmware open, do the wonderful little crack, and end up with a basically a SSA 3032, which is 9 kilohertz to 3.2 gigahertz, tracking generator, measurement package, all that wonderful stuff. So yeah, and the 10 hertz resolution, RBW resolution bandwidth, all that wonderful good stuff. The negative 98 dBc per hertz phase noise, so it's pretty good. And yeah, so anyway, guys, anything else before I go? Otherwise, I'm going to call it a night. And tomorrow, if I am able to get the thing, like, you know, if I don't like accidentally miss the post guy and I don't get to sign for it because a signature is required, and yeah, they're not going to leave it for me. So anyway, guys, anything else before I go? Questions? You guys can email me anytime. Please, though, guys, when you email me, per root hertz. No, did I say that? I haven't. I swear I haven't started. I mean, I haven't done anything tonight. Like, I didn't, you know, hit the Crown Royal stash. Did I say per root hertz? No, I didn't. I said resolution bandwidth, RBW. You got me. Did I really say that? I mean, did I really say that? You're going to make me go play this back. I say per root hertz. I said 98 dBc per hertz. Per hertz phase noise. According to the specifications. Negative 98 dBc per hertz at 10 kilohertz phase noise. Noise bandwidth. Oh, it is a noise bandwidth on this thing. That's resolution bandwidth. Phase noise. Negative 161 dBm per hertz, average noise level. It's pretty good on paper. There's a guy who did a review of it. Let me see if I can find that, because it's got to be like the best review on the instrument. Small Box Adventures. How are you? Let me see if I can find it. Right quick. He did a very good review of it. And I'm talking about, you know, not Dave Jones-ish. I mean, Dave's okay. I'm going to link this video. It's a very good review of it, incidentally, guys. I mean, it's a really good review. This is a very good analysis of the instrument. It runs 25 minutes. I thought he did a very, very good review of the instrument. Like, I don't think I couldn't do any better, honestly. I mean, he did a very good job of reviewing the instrument. So I would suggest watching his review of the instrument. You know, I'm just going to show it and play with it. And yeah, he sat there, he did real measurements, he did, you know, he looked at everything, because he's got a listing here on his video. Unboxing, discussion of inputs, the screen, the build quality, AM, FM demodulation, average noise measurements, phase noise, spurious readings, possible shielding issue. I don't remember catching the shielding issue. Amplitude accuracy, tracking generator. I remember him going over the reflection bridge. And I remember him saying that the reflection bridge that you could get from Siglent for this unit was sort of subpar, which is unfortunate. So his take on it was just to go to mini circuits or any of these other, heavy duty RF engineering firms that make reflection bridges, and get a reflection bridge from one of them, because you're going to end up with I think it had some issues with frequency response across the range of the instrument. I think it had some valleys in it, and some issues with the flatness of the response of the reflection bridge. So certainly would be something that Siglent could probably sort. But his suggestion was to, if you're going to go get a reflection bridge, go get one from someone else, and not the Siglent one. But the instrument overall was fine. So anyways, that was his take. I suggest looking at this guy's video if you're interested in, because it's sort of a quasi RF engineering thing as well. So he does some sort of little RF tutorials in there as well. As far as setting up the instrument for test and all that wonderful stuff, I would suggest that. So anyway, guys, it's been fun. I'll let you guys not stare at a radio with a board in it. Call it a night. You guys have a good one. We'll give it a go tomorrow, and I'll see what my impression of it is. Which like I said, I don't think I'm going to be able to top anything that he did. I think this guy covered this instrument extraordinarily well. Dave tore it down. Dave Jones, he let him tear it down. He compared it, I think, to a Rigel. But on paper, the Siglent's a lot better than the Rigel. On paper, and this guy's review, pretty much, he came to the same conclusion as the paper. He measured it, and it was within the specifications that Siglent had on paper. So it was definitely in line with their specs. So there wasn't anything inflated there. So yeah, I'll have it tomorrow. We'll find out how well it works for me, and maybe I'll hook the tracking generator up to the this Agilent 4352B that I have over here, and we'll measure its phase noise and see if it's on par with what they say it is. So anyway, guys, it's been fun. Appreciate the test and the suggestions on the video, and I'll send some emails around and see if I can't figure out what to do about the video and the color, and figure out why this matte isn't quite blue and all that wonderful stuff. If it's something I can do about it, because I really hope that there is something I can do about this, and maybe I'm hoping it's just something as simple as lights, lighting that will sort it, and I can just change some stuff up. So anyway, guys, it's been fun. Good night till tomorrow. Cheers for now. Questions, comments, email me, let me know. And till next time, see ya.